And in this video, I'll be explaining about the network policy in Kubernetes. This is also one of the most important topic for Kubernetes security certification exam. So let's start. Basically, network policies are the firewall rules which work at OSI layer 3 or 4, which is a network layer. And the scope of the network policy is limited to namespace only, which means we have to define separate network policies for different namespaces. By default, all the pods can communicate with each other within namespace as well as inter namespaces, as there is no network policy defined. So to make Kubernetes cluster security compliant, a default deny blanket policy is created first, which will block all the communication between the pods, and then specific network policies are created wherever we need pod-to-pod communication. So network policies are defined in three ways: pod-based policy, namespace-based policy, and IP-based policy, which I'll show by demo in this video. There is one important point to note that if we have defined default deny policy, then for communication from pod 1 to pod 2, we have to create egress policy for pod 1 so that data can go out, and ingress policy for pod 2 to receive the traffic. So let's talk about the default deny policy. So default deny policy will block all the ingress and the egress traffic in the namespace. And this is the snippet of the default deny policy. So the kind is network policy. In the metadata, name is defined, which is default deny all. You can give any name. Namespace is not defined here, which means this policy will be applied on the default namespace. If you want to apply this policy to a specific namespace, then you have to define the namespace here, which I'll show you in the demo. There is nothing defined in the pod selector. That means this policy will be applied to all the pods. And this policy types are ingress as well as egress. So the communication for both ingress and the egress traffic will be blocked. Let's check the scenario 1. In the scenario 1, we'll first create a namespace development. And then we'll create two pods. One is application pod, another one is database pod. And by default, all the communication will happen between application and database pod. And once the default deny policy will be applied, then the communication will stop. So let's see this in demo. I have Kubernetes 2-node cluster ready. So let's check the nodes. So it has one master node, another worker node. So first of all, let's create a development namespace. Namespace is created now. And now we'll create two pods. First one will be app pod, another one will be DB pod. Let's select the namespace. And using the run command, we'll create both the pods. And we'll choose the image as nginx. First one is created. Now the DB pod, and the DB pod is also created. Let's check the pod status. Both the pods are running in the development namespace now. Now create the service for these namespaces so that they can expose port 80. First service is created. Same for the DB pod too. Let's check the service created. We can see now two cluster IP services are created for both app pod as well as DB pod. Now from app pod, we'll try to reach out to DB pod. This is exec command. Now we are into the pod. Let's do the curl on DB pod. And you can see a welcome to nginx page is displayed. So this means the communication is working. Let's check the same from DB pod. And there is another way. Instead of going into the bash and running from inside within the container, we can run directly from here. And you can see the communication from both DB to app and app to DB is working fine. So now let's create a default deny policy. It will be a YAML file. And for policy, let's navigate to Kubernetes documentation. This is network policy documentation, and we'll go directly to default deny all ingress and egress traffic. Let's copy this policy and paste it here. And we'll make the required changes. First, we'll change the name from default deny and pod selector. It will be for all the pods. And let's add the namespace too, because we are assigning this policy and on the namespace development. Policy is created now. Let's apply this policy or create this policy. Now the default deny policy is created. And then development, in the development namespace, get network policies, and you can see default deny policy is there. Now again go back to app pod and run the same curl command. As you can see now, the app pod can't reach to DB pod because all the ingress as well as the egress traffic is blocked. Try the same thing from DB pod, and same is happening here. That means the communication between the pods within the namespace is now blocked. So let's go back to our slide deck. Now for allowing the traffic, we have to define specific policies, both the egress as well as ingress policies. And there are three different types of policies. First one is IP based policy, where we have to define the IP block. This can be defined both in the ingress as well as egress. Namespace based policy, where if we want the traffic from one namespace to another, then we have to define the namespace selector. And the third one is pod based policy, where we have to define the pods, and this will be specific to that particular pod. You can define the ports. If you'll not define the ports, it will be applicable for all the ports. So let's move to scenario number 2. In this scenario, we have namespace development, which is already there. App pod and DB pod both are already there. Now we want the communication from app pod to DB pod. So we'll define the egress policy on app pod so that traffic can go out, and ingress policy on the DB pod so that it can accept the traffic from app pod. So let's check this in demo. Let's first create the egress policy for app pods. This will be a YAML file. I'll copy the code. All these YAML files I have uploaded in GitHub, and I have provided their link in the description of this video. So the name is allow egress, namespace is development. It's selecting the pod based on its labels, which is run app pod. This policy will be applied on the app pod, and the traffic from app pod can go to DB pod. So here we have defined the pod selector for the DB pod. Let's save this. Let's quickly check the labels of the pods. Show labels. As we created the pods using the run command, so you can see there is a run label applied on both the pods. Now create the ingress policy for the DB pod so that it can receive the traffic from app pod. Let me copy the policy. Same way you can see now the name is changed to allow ingress development namespace. It's applied on DB pod to the app pod. Now both egress and ingress files are created. Let's create the policy now. Let's first create the ingress policy and then create the egress policy. Now both the ingress and the egress policies are created for the pods. Let's quickly check in the development namespace. As you can see, there is a egress policy which is applied on app pod and an ingress policy which is applied on DB pod. Now we'll test the communication from app pod to DB pod. Still there is no communication, and the reason here is because default deny policy is blocking the DNS traffic too. So there is a workaround for this. Either we can allow the DNS traffic in the default deny policy. Another workaround is to provide the IP address of the pod instead of the name. As you can see, the DB pod IP address is 05 app pod IP address is 04. So let's check the command again. Instead of the name, we'll provide the IP address, and we can see our page is reachable again. Now let's try the same from DB pod. I'll provide the app IP address, which is 04, and it's not working because we haven't defined the ingress and the egress policy for the communication from DB pod to app pod. So that's all for scenario 2. Let's go back to slide deck. There is a scenario 3. Now we'll create another namespace, which will be production namespace, where we'll create the live pod. And now from app pod, which is in development namespace, we want to connect to production namespace live pod. First of all, we'll create the default deny policy in the production namespace so that all the traffic are first blocked, and then we'll allow the traffic within the different namespaces. So let's check this in demo. First create the namespace. Namespace production is created. In the production namespace, let's create one live pod. Image will be the same nginx. Let's check if the pod is running. We can see the live pod is running now. Let's create the default deny policy for the production namespace. This is the default deny policy. Namespace is production, and it will be ingress and egress policy. Let's change the name to production. Create the policy now. Now the policy is created in the production namespace too. As you can see, the default deny production policy is there. So that means the communication from the app pod to the live pod is not happening, and it's the same vice versa. Now we'll create the egress network policy for app pod so that it can communicate to the pod in the production namespace, and we'll create the ingress policy for live pod so that it can receive the traffic from the app pod which is in development namespace. So let's first create the egress policy. So in this policy, we have defined the name. This is from the development namespace. This will be applied on the app pod. This will be egress policy. And instead of the pod selector, we have given the namespace selector. And the namespace is production. Let's save this. Now, before creating this policy, we have to create the namespace label on the production namespace. YAML. So you can see there is only one label right now, but we have defined the NS label. So let's assign this label. Now the production label is assigned. Let's create the egress policy. Egress policy is created now. Now we'll create the ingress policy for the live pod, which is in production namespace. This is a network policy with the name ingress namespace. This is for production namespace. This will be applied on the live demo pod. This is an ingress policy, and the namespace selector will be for development. Same way, before creating this policy, we'll assign the label on development namespace. As you can see, the label is assigned to the development namespace too. Let's create the policy. Allow ingress namespace. Same way, as you can see, there will be an egress policy defined in the development namespace. I have forgot to create the service for the live pod. Let me create the service. Expose pod live pod on port 80. So the now service is created. Now let's first check the IP address of the pod because the name resolution will not work. The IP address is 0.6. So let's try the communication from app pod to live pod. And you can see the welcome page. So our network policies are working. So that's all for the demo. There are a lot of things which you can do using the network policies, and it is one of the most important security parameter in the Kubernetes. So you can use the IP blocks, namespace selector, pod selector. You can define different pods based on your requirement. I hope you liked my video. So pod security policies are the cluster level resources which defines the security conditions of the pod, which means these provides an extra layer of security over RBAC. Let's take an example. If you have defined RBAC for a user to create pod and the user account is hacked, then the intruder can create a pod of any type and then use the security loopholes of the pod to access the worker node or the other pod's data. So let's see this in a demo. I have a two node Kubernetes cluster. One is master node, another is worker node. Let's first create a namespace. This namespace name will be lab demo. And in this namespace, we'll create two pods. One is regular pod, which we normally create, and another one is privilege pod. So let's first create a regular pod. So the kind is pod, name is regular pod, namespace will be lab demo. It's an Ubuntu pod. I provided this command so that it will be keep on running. So let's create this pod. Let's check the pod now. So the pod is running. Now I'll log into the pod to check the different processes as well as the different mappings. I'm into the pod now. So let's first go to dev where all the devices are mapped. As you can see, it only shows the information of the pod only. Let's run ps-ef. So yes, the sleep 5000 is running because that we have provided in the command. There is no other process which is showing. So let's come out of this pod and create another pod, which will be privilege pod. So in this pod, we have defined the host PID, which is true, and the security context where the privilege will be true. Let's create this pod. Pod is created now. Let's log into pod now. I'm into privilege pod. So first thing, let's check the device mapping. As you can clearly see, all the disks which are assigned to the operating system are also seeing here. So which means we can map these disks and we can make the changes to any file system. If we'll run the mount command or if we'll run the df-h command, here you can see the dev sd1 is mapped to etc host. If we'll run fdisk-l, we'll show you all the file systems which are created. And if an intruder has got the access through this pod, then file systems can be accessed. Now let's check the different processes. Now you can see instead of just showing the processes for this pod, so all these processes will be on the other pods which are running as well as the worker node processes which can be killed, which can be used to get more information. So using the pod security policies, we can prevent this from happening. Let's go back. When we create the pod security policies, we have to enable the pod security policy admission controller plugin in the API server so that the API server can check the creation of pod against the pod security policies. There are around 16 control aspects for the different pod which can be defined in a pod security policies. So here are the 16 control aspects and I have marked few in yellow which are the most important ones and which will come in the security exam too. There is one important point to note that always create pod security policies, roles, role bindings first and then enable the admission controller plugin. Otherwise, no new pod can be created. Even the Kube API server will stop running after making the change. I'll show this in a demo shortly. So the pod security workflow. Most of the cases we create permissive policy for the kube system. We don't want to restrict kube system processes or the pods because most of the system pods, networking pods, metrics pods are running into the kube system namespace. So we don't want to restrict kube system namespace because it can affect the running of the cluster. So we provide the permissive policies, we create a cluster role for that and assign a role binding to the kube system. However, for other namespaces, we create a restrictive policy, we create the cluster role for that policy, and then we create the different role bindings which we assign to different authenticator users in different namespaces. Let's see this in demo. So let's enable the pod security policy admission controller plugin without even creating the policies. I'm picking up the name from the documentation. Soon the process will be killed. So now you can see the process is gone and it should come up quickly. API server pod is not running, so let's change it back now. Now you can see the Kube API server is up. Let's run the command. Now you can see both the pods are running. So let's create one permissive policy and one restrictive policy. You can find the same information here too in the documentation. Here the privilege is false, but for the permissive policy we'll give it as true. And I'm not restricting anything for now. So let's create this policy. And one more important point, the pod security policies are deprecated from version 1.21. That doesn't mean they are removed. That means they will be unavailable from 1.25. And for now, because they are being asked in security exam, so they are important. And for versions which are lesser than 1.21, still need the pod security policies. Let's create the restrictive policy. In the restrictive policy, we have mentioned the privilege should be false and the host PID where we were checking the worker node processes, that should also be false. So it will not show the process IDs. Let's create this restrictive policy too. kubectl get pod security policies, and yes, both the policies are shown here. Now we'll create the two different cluster roles. Let's copy the cluster roles from the documentation. First one, we'll create the permissive role, and we are defining this for allow all, which is permissive policy. Let's create restrictive role. Both of these are cluster roles, so that means they are defined throughout the whole cluster. And the resource name will be limited allow, which is the name of our policy. Let's create both these roles. First one is created. Let's create the another one too. Now both are created. Let's check. As you can see, permissive role. Same we can find restrictive role. That's good. We have both the roles defined now. Now let's create two different role bindings. First one for the kube systems so that all the system processes can run smoothly. And the second one so that we can restrict the different users to create privilege pods. So let's create role binding. So now we are not creating cluster role binding because we are defining specific to the namespace. So we are creating the role bindings here. This one is for kube systems. And we are defining this for system authenticated users within the kube system namespace. So the permissive binding role is created. Now let's create another one. This will be restrictive role binding and the namespace will be lab demo. And the same group will be system authenticated. So let's check the created role. Now you can see the restricted binding role binding is assigned to this namespace. Now we'll enable the pod security policy admission controller plugin. So let me fetch the correct name, security policy. And if you'll run the kubectl command here, so it's not running. Check the process. Check the API process. API pod is up now. So now we can see both the pods. Now let's delete the privilege pod and check if we can create it again now. So pod is deleted now. So we have privilege pod YAML file. Let's create the pod with the YAML file. So as you can see, host PID is not allowed and the privilege containers are not allowed. So that means pod security policy is working. And so now none of the user can create the privilege as well as host PID pods. Same way you can define different control aspects which you can test from the documentation. I hope you liked this video. Please like and subscribe to my channel.